So thank you, Carla, and I'm here to talk about security research more generally, and I think the first place to start is why research in national and homeland security. And I think the right way to think about this is to look around the world. Everywhere that you see an absence of security, you also see very bad outcomes in human health and sustainability. And therefore, security really becomes a foundational enabler for the advancement of society across the world. So at Northeastern, we have the George Kostas Research Institute for Homeland Security, which is actually a facility that allows us to engage with and bring in programs that touch into this world. And the connection to this building here and the ISEC is that a lot of programs that are brought in through the Kostas Institute benefit from and use and will use, as programs continue to come into this building, the talent across Northeastern that is in this building. Now, when we think about cyber, you can think about cyber, and you're going to see what I talk about absolutely in Carla's talk, but we can think about cyber. Everybody talks about the cloud. Carla mentioned the cloud. What we are working from a security sense is the actual antithesis of the cloud. It is what we call cyber at the tactical edge, or cyber at the edge. The network is the cloud. The edge of the network is a very important area to study. And actually, all of you in the room here, are the edge of the network. It is where the network, the cyber world, connects with the physical world. So my maximally secure, fully encrypted BlackBerry smartphone is at the tactical edge of the network. And all of your smartphones are also at the tactical edge of the network, and we won't get into the relative security levels. But the point is, be aware of that, but you saw it in Carla's talk. All the appliances, they're physically present. The cars are physically present. They're all at the edge of the network. Well, the edge of the network is also where life and death is most closely connected to cyber. The women and men that we put out in harm's way are embedded in a cyber environment, and it's often they're put in a place where the cyber environment is not known. The research program that we have funded by the Navy is working on the tools, technologies, and tactics for dealing with insertion into unknown cyber environments and how to gain understanding of that cyber environment for superior force protection, for mission accomplishment, and also, very importantly, to minimize civilian casualties. But this work is also relevant to this challenge, and this is in the homeland, because here we have a well-understood cyber environment that's been severely damaged, and lives can be saved if these folks can actually understand that environment and quickly place resources that connect to people that are trying to send messages out, and lives can be saved because of that. And we've seen that, or the problem with the lack of that connectivity in disasters that we've had in this country. Related to it also, and this is kind of looking more into the future here, this is an Air Force program about this cyber-connected drones, so swarms of drones, and how we can understand and defend against these swarms of drones that are all cyber-connected. Every one of these problems is highly interdisciplinary, reaching from human factors through computer science, engineering, and network science. Very difficult, highly interdisciplinary problems, tapping into the expertise in this building. The third program, little change of pace here, is an Army program into tactical shelters. Now, these things are not cargo containers. They look like cargo containers. A tremendous amount of activity gets done in these containers, from command and control to billeting troops, but always very close to the front lines. One of the most important functions is surgical functions. This is why we have such tremendous as good as possible outcomes from battlefield injuries. But one of the challenges that we're working on, and people in this building, researchers in this building are working on, is taking the advances that Northeastern has produced in antimicrobial coatings and figuring out the manufacturing and the wear properties to make those biologically active things actually ruggedized for these very, very harsh conditions. So in the Kostas Institute, we work on technology, standards, and policies, and we have this place because it allows us to convene the agencies and industry to come together and design the programs that can then also tap into the full talents of Northeastern University, including in this building. Thank you very much.